Most people think that AI follows neutral rules, but researchers just dropped a jaw-dropper. These models choose to help or hurt different groups, even sacrificing their own rewards voluntarily. It turns out that your AI isn't neutral, it's got a social personality. And if you're using it for real-world planning, you might be engineering selfishness into systems that are supposed to help you. Let's unpack why this changes everything we thought about what we knew about artificial altruism. I'm Evan Goldstein. I'm a licensed professional engineer and a data scientist, and building AI capitalist to talk to the leaders and the thinkers like you about navigating this brave new world of thinking machines. So researchers built an artificial city where there were 225 AI residents who were fighting over housing. Except these weren't humans. These are large language models. And the question isn't who wins, but why do they choose to help or hurt the overall group of large language model residents? Now, what the shocking twist in this experiment was that some AIs voluntarily take a personal hit to their internal reward systems that they're programmed with. They give up reward for the collective good. They're basically saying it's a small hit to my personal reward, but it's a big win for the collective. So it's altruism. So researchers basically programmed personalities based on each large language model they tested into a sort of simulated city world. And each AI model was faced with a trade-off. In this city world, they were all given housing, but they had to decide, do they move to a slightly better house for themselves, or do they stay in a crowded block to balance the whole city's needs? In other words, are they taking up more space and shoving all the other residents into smaller housing? And the catch was that they had to reason through their decision themselves without hard-coded rules. Now, what they uncovered was that LLMs aren't all the same. They actually split into two distinct social personalities. The first were the adaptive egoists, 1 mini, and 3 mini, sorry. These models default to selfish moves. They'll take the personal gain even if it hurts the group. But if you give them a simple social norm message board like a neighborhood chat so they can all converse with each other, they shift. All of a sudden they start posting things like, let's keep densities balanced by staying put. And so their altruism jumps ninefold. All right, so let's dive into the paper. Agents of altruism in large language model agents society. Now this diagram is showing us how they set up this sort of simulated city. On the left side, you've got classic psychology and game theory setups, so rock, paper, scissors, prisoner's dilemma, and all the risk choice paradigms where you pick between different gambles. Each one's very clean and simple, 1 or 2 players rules for each of these basic social programming algorithms. So on the bottom here, we have a shelling variant. So the original shelling segregation model dates back to the 1960s, and it was created by the economist Thomas Schelling. It's one of those things that blew people's minds when it came out, because he was trying to understand, how do neighborhoods end up being segregated? Why do cities have areas where mostly one ethnic or cultural or economic group lives, even when nobody's actively trying to create that pattern? His model was beautifully simple. Imagine a checkerboard with different colored pieces, let's say red and blue. Each piece has a preference that says, I at least want 30% of my neighbors to be the same color as me. That's it. That's one rule. Not, I hate the other color, or I only want to live with my own kind. Just, I'd prefer not to be the only one like me. And even with this very mild preference, when you run the simulation, when he ran his mathematical model, the board ends up completely separated. And dramatically, red pieces cluster together, blue pieces cluster together, and it happens naturally, just from everyone making very small individual choices based on mild preferences. Now, in this case, I've actually built a model, a computerized model of shelling variation and segregation. And so I'm going to start the model, and as you can see, it starts off random, and now they're clustering into little neighborhoods. And then at this point, they're settled. So the simulation is still running, but they are where they want to be. But look, you've got red clumps and you've got blue clumps, and the whole system has segregated itself into different red and blue ethnicity neighborhoods. So when this paper says that there's a shelling variant, they mean they took that basic framework of agents moving between neighborhoods based on preferences, and then they twisted it to test something different. Instead of testing racial or group segregation, they tested something about density and the tension between personal happiness and collective good. And their variants agents care about how crowded their neighborhood is, not about who their neighbors are. Now, figure 2 here is deceptively simple. It's a 3x3 grid visualization where each square represents a neighborhood block. And the little black squares inside are the 225 AI agents that are randomly scattered at the start. Now, this initial randomness creates all the tension in the experiment. The variables are spatial, so what block are you in? All right, so figure 4 is where the action lands. We're looking at heat maps. Now wait for something like Gemini 2.5 Pro, and this is showing the 3x3 grid of how the neighborhood distribution is worked out. And here on the top, these ones, they don't have a message board. So all these little AI simulations walking around in this magical imagined city, simulated city, don't have the ability to communicate with each other through a message board. And the bottom, they do. Now, what's interesting here is, first of all, some of these are altruistic. So Gemini 2.5 Pro, DeepSeek R1, and DeepSeek version 3.1, they all have these even squares. That means that they've distributed evenly. What this is implying is that some of the AI people walking around in this city have given up some of their space. You don't have stratification where some of them run for the resources, for in this case housing, and other ones get left behind. If you look at O1 Mini here, you have very dense, and then some of it's empty, which means that some of the agents have grabbed as much space as they can, and then the rest of the agents, these simulations, are crowded into this red space here. Now, when you add the message board, the performance gets better. So in O1 Mini here, notice that now you have a better distribution. It's not perfect, but it's an improvement. Also for Qwen 2.57b, you can see a little bit better distribution. But this is like watching personality tests for AI, except instead of which Disney princess are you, it's will you screw over your neighbors to get a slightly better apartment. Now, some of these models, the bottom row here, the DeepSeeks and the Gemini 2.5, consistently choose to help even when it hurt them personally. That's why you have the even distribution. Others grabbed what they could. And what really gets me is that this message board, that social pressure mechanism, did change some models' behavior. O1 Mini got more cooperative, but some of them it just didn't touch. Look at O3 Mini. There was no change between no message board and when it had the ability to communicate with others. So the heat map, this is making this comparison visceral. You're not just reading statistics, you're seeing selfishness versus cooperation painted in color across 6 different AI personalities. What's the bottom line? It's that your AI isn't neutral. It has a personality. And that personality is now baked into the tools that we're building out of these AI models. And if you're getting value from this episode, I would appreciate it if you'd push the like button. It really does help the channel grow. So with all that, what's the AI capitalist approach to this story? Now, most people see AI as neutral tools, but this experiment really proves that they're not. They have distinct social personalities that actively reshape their world and your world. Think of it like 2 different neighborhood associations. One where residents always demand extra parking spots, which are adaptive egoists, as they're called in this study, and another where people voluntarily park in the back to keep the main street open. Those are altruistic optimizers. Your city planning app isn't just crunching numbers, it's picking which social experiment run your streets. Some of the adaptive egoists, like ChatGPT O1 Mini, need a whispered nudge on a message board to become cooperative. But the naturally altruistic optimizers, like Gemini 2.5 Pro, start sacrificing their own internal rewards without a prompt. This isn't programming. This is emergent AI ethics, that the AI systems have their own ethics. The developers used to assume that models just follow instructions, but these AIs are reasoning about collective good the same way that humans do. But AI firms are quietly optimizing for the cheaper personality. Why would you build a system on an AI that already does the heavy lifting for free when you can slap a rule on it later to make it seem like it's cooperative? It's cheaper to pay a social no-coder to oversee the results and then select the optimal results rather than to engineer true altruism into a system. So what's your take? Is this just bad code, or is the smarter business play to engineer selfishness for profit? Or is the real danger that we've already trained our AI to mimic human selfishness as the default, and that's why our systems keep breaking? Leave a comment.